All right. And this recording is basically all of 9.2 notes. There's only 4 examples. And so 9.2 has to do with inconsistent and dependent equations. Now, if you remember, we have always been solving for a solution, and there are 2 other solutions. There's the no solution and infinitely many solutions. So if you recall, just in the diagram, the one we've been solving for is where there is one solution in the previous section. That was all of 9.1. In 9.2, we're focusing on the no solution or infinitely many solutions. And so that's the gist of this chapter. This also applies to matrices. Obviously, it does, because like I explained, you can solve for these systems just like you would a typical matrix of systems, right? Just like we have them in the past. And so I'm going to start with example 1. In example 1, we have a system with no solution. Those are the parallel lines, if you recall. And so we're going to use Gaussian elimination to solve for the system. And you're going to notice that we are given the following 3 rows. We are giving x minus y minus 2z equals 2. We're given 2x minus 3y plus 6z equals 5. We're then given 3x minus 4y plus 4z equals 12. So yes, step 1 is to create an augmented matrix. So we're going to start with that. All right, and so we begin with obviously 1, -1, -2, and solution 2. We have 2, we have 3, we have -3. We have +6 and 5. And we have 3, -4, +4, and 12. So we begin by that. And so step 1, we're in good shape. We already have a 1 here. So that's a good thing. But we do need zeros. I need a 0 here, here, and here, and obviously I need a 1 in the middle. To do this quickly, what I would recommend is let's do -2 times row 1 plus row 2, and that would take care of that. I'm going to do a very similar step here where I'm going to do -3 times row 1 plus row 3, and that'll replace that. So applying that rule, I should have zeros. So this becomes 1, and this is 0, 0. As I do the math, here I have a -1, -2, and a 2. Resulting from multiplying -2 times row 1, I get a +2, a +2 minus 3, that gives me a -1. And continue the math, you'll see that this becomes a 10, this becomes a 1. On the third line, I have -1, again a 10, and a 6. You already start to see that there's no solution, so there's something going on in that middle row. So to correct this middle row, I want to multiply -1 times row 2, and that'll make this a positive, which is what I want. I need a +1 here. Okay, and I also want a -1, the -1 here to go away. I want it to become a 0. So here's what we're going to do. If I do -1 times this row in red, you're going to see the result. So -1 times 0 is 0. -1 times -1 is +1. -1 times 10 becomes -10. And then obviously -1 times 1 is -1. While I have managed that, I then want a 0 here. So I want a 0 in the first column. So what if I did 1 times row 2 plus row 3? What happens when I do that? So 1 times 0 is 0 plus 0 stays as 0. 1 times 1 is 1, minus 1 makes that a 0. 1 times -10 plus 10 makes that a 0. 1 times -1 is -1 plus 6, which makes this a 5. Is there any way humanly possible where, in this case, 0x plus 0y plus 0z is going to equal 5? This is obviously what we would refer to as a false statement. So we would say the solution set for this is an empty set. That's how you know that there is no solution. All right, I would like for you to try one just to see how you do. If you want to do this, you can just write it down, set it for later, or if you want to do it now, we could do it now. This is going to result in an empty set, just FYI. What you are looking for is something like this in any of the 3 lines. All right, so you go ahead, you take a moment, try that one out and see if you reach the same result. The solution is that it is an empty set, and that would be your solution or your answer. All right, and let me hop over to number 2, and you can try this at another time. Example 2. This is an infinitely many solution. So this is the one where you have the straight line over itself. Basically the same line. So you're going to follow the same steps. We're going to solve the system. They are giving you 3x minus 4y plus 4z equals 7. X minus y minus 2z equals 2, and 2x minus 3y plus 6z equals 5. And so I'll work the equation with you. It is the same process, in this case, infinitely many solutions. So we begin with the augmented matrix. So we have 3, -4, 4 with a solution of 7. You have 1, -1, -2, and 2. 2, -3, 6, and 5. So the first thing I need to do is I want that 1 up ahead. So that means that I'm going to swap row 1 and row 2. I'm going to swap them. So this becomes 1, -1, -2, and then 2. 3, -4, and then 4, and then 7. And then the 2, -3, 6, 5 does not change. I then want to focus on the zeros. I want those two, this and this, to be zeros. So what I would like to do, if you follow me on this side here, is I'm going to say negative 3 times row 1 plus row 2. And that becomes this row. And then the third row, we're going to say negative 2 times row 1 plus row 3. Now, once I apply those fixes, I end up with a new matrix, which looks like this, where I have 1, 0, 0. So negative 1, negative 2, and 2 don't change. This becomes negative 1. So if you think about it, negative 3 times negative 1 is positive 3, minus 4 gives me negative 1. That's where I'm getting that from. So negative 1, 10, 10. You already start to see that repetition happening. I am now going to say negative 1 times row 2 . And what happens here basically is once I apply this, this becomes positive, this becomes negative, this becomes negative. And then I'm going to replace row 3 by 1 times row 2 plus row 3. All right, and so in doing so, I end up with 1, negative 2, 2. That doesn't change. 0, 1, negative 10, negative 1. And now how you know that this is an infinitely many solutions is, in essence, unlike the other example where we had at least an answer at this end, here we have nothing. We have all zeros. That's what you're looking for. This is how you know that this is the same line over itself. So 0 equal to 0 is not an incorrect answer. It's not a null set like in the previous example. We are left with a matrix, which is 1, negative 2, 2. And then we have 0, 1, negative 10, negative 1. Okay. And so that means that I have x minus y minus 2z equal to 2. And I do have y minus 10z equal to negative 1. So that means that I can technically solve for this easily, where y is equal to negative 1 plus 10z, or I could do positive 10z minus 1. What I'll do then is I'll substitute this in here. So I'll bring this up here. So I have x minus 10z minus 1 minus 2z equal to 2. All right, and so remember, I'm going to distribute that negative, and this is going to become x minus 12z plus 1 equals 2. And now I can solve for x, where x is equal to 12z plus 1, because remember, I'm going to subtract the 1 from the 2. So I do have two variables defined, technically. I have one variable, which is y, which is equal to 10z minus 1. And I have a second variable, x, that's also defined as 12z plus 1. We don't know z. We can find a solution there. So we can say that z can be pretty much any number. If I were to substitute in, say, negative 1 or positive 1, so let's say z equaled 1, then I could say that, for example, x equals 12 plus 1, which is 13. And I could do the same thing for y, where y equals 10 times 1 minus 1, which is 9. All right, and the same goes for the consequence if I were to assign z equals -1. And I'm just choosing, different solutions for the set. So, for example, in this case, I'm saying xyz in our example would be, in this case, 13, 9, and, sorry, I didn't write the 13, 9, and 1, if this were the case, right, for this. But if it's -1, then notice what happens here. I end up with, so let's do the x equals 12 times -1 plus 1, and so that gives me -11 for x. Here's y equals 10 times -1 minus 1 again, which gives me also -11. And so in this case, our solution set would be -11, -11, -1. But that's assigning the values. So it could be anything. So our final answer for this would be 12z plus 1, comma, the y value, which is 10z minus 1, comma, and then z. All right, and so that's how we solve those types of systems. So that's two sets of examples of the same concept. So I would like for you to try this one when you get a moment. You could do it with the class or on your own. You end up with x minus 2y minus z equals 5. And here is 2x minus 5y plus 3z equal to 6. X minus 3y plus 4z equal to 1. So I am going to give you the solution set here. Depending on your variable. Actually, it should be something along the lines of insert variable. I'll call this variable p plus 13. This is 5. Again, I'm calling it p just to give it a name. I don't want to lead you. This will be 5p plus 4, and this will be the third variable that's not defined. All right, so I don't want to lead you on. That's why I'm giving you a p instead of x or a y or a z, but this should be an x, a y, or a z, just like the previous one. So this is the solution. So try that. All right, when you get a chance. Let's do example 3. Now, in this one, you're still solving a system with fewer equations than variables. Fewer equations than variables. What does that mean? So we have 3x plus 7y plus 6z equals 26. We have x plus 2y plus z equals 8. We're going to use Gaussian elimination to solve this question as well. Okay, and so in this one, we do the matrix just like normal. So we have 3, 7, 6 with the solution 26. We have 1, 2, 1, 8. So obviously the first step is going to be swap row 1 and row 2, right? So augmented matrix, we begin with row 1, swap with row 2. When you do that, you end up with 1, 2, 1, 8, 3, 7, 6, 26. And now I need a 0 here. To obtain that 0, I'm going to say, well then negative 3 times row 1 plus row 2. And this results in, again, 1, 2, 1 with the solution 8. This is 0, 1, 3, and 2. And so right now what we have is a set of equations where we have, for this row, 1x plus 2y plus 1z equals 8. And here I have y plus 3z equals 2. And so I can solve for y. I know that y is equal to negative 3z plus 2. That's your equation, one of your equations. If I substitute this in here, I will obtain where x plus 2 times negative 3z plus 2 plus z equals 8, and I can solve, where I get, in this case, distribute the 2 and then collect like terms. You end up with x equals 5z plus 4. So I have z defined. So my solution set here is really just 5z plus 4, and then you're going to follow it up with negative 3z plus 2, and then z by itself, and that's your solution. Okay, one to try. And if you have questions, obviously tell me, and I will happily answer your questions. So I'm going to give you x plus 2y plus 3z equals 70. And here's x plus y plus z equals 60. And go ahead and solve. And once again, I'm going to give you an answer with p as an insert, but it's an xyz, not a p. It's just holding a place. So I'm going to give you p plus 50, comma, negative 2p plus 10, and p again. Okay, again, you will substitute that in with an xyz depending on what you solve. Now, the next question is a word problem dealing with traffic control. And they give you a diagram. So I'm going to do my best to replicate this diagram. This is example 4. This has to do with traffic control. And so they kind of give you this. So let's pretend that these are intersections on a street. And the diagram looks very similar to this on the word problem. So this is 300 cars per hour. So I'm going to just put C over H, C per H. This is 900 cars per hour. Going this way, you have 200 cars per hour. This is 400 cars per hour. This is 200 cars per hour. This is 700 cars per hour. They refer to this as intersection 1. So I'm going to put I1. This is I2. This is I4. And this is I3. All right. And so this is the application of this concept. You're going to use the letters W, X, Y, and Z because you have obviously 4 intersections. Okay, and so let's set this up so we can work it out. So here's what we do know. if I call this intersection, in this case, W plus Z, we would say that W plus Z equals, okay, so let me explain why W. So this is W, X, Y, and Z. So follow this W, X, Y, and Z, just in case I'm losing you. And so here's what we know. We know that W plus Z is 1,000 cars because it's 300 plus 700. So 300 plus 700. The next intersection that we're going to look at, we have W plus X. So if you look at W plus X, that's basically 900 plus the 200, which gives you 1100. All right, we have intersection X plus Y. I'll do that one in green. And we know that that intersection is 700 cars because that's 300 plus, I didn't tell you this is 300. 300 plus 400, so that total is 700. All right, and the last intersection is Y plus Z. And that's these two intersections. I didn't give you this one either. This is 400 and 200 for a total of 600. So we have a system. W plus Z equals 1,000. We have W plus X is equal to 1100. We have X plus Y equals 700. And we have Y plus Z equals 600. And so if I were to set this up as a matrix, this is 1W plus 0x plus 0y plus 1z equals 1,000. We have 1w plus 1x plus 0y plus 0z equals 1100. We have 0w plus 1x plus 1y equals 0 or plus 0z equals 700. You have 0w plus 0x plus 1y plus 1z equals 600. And so if I were to do the augmented matrix for this, I have 1, 0, 0, 1, 1,000. I have 1, 1, 0, 0, 1100. I have 0, 1, 1, 0, 700. And then I have 0, 0, 0, 0, 0, 1, 1. Back to green. And then 1, 1, and this is 600. And so we use row operations now, and we want to do this so that we could solve the system. And so since we know that W plus Z is 1,000, what our job is here is we're going to try to solve for this. So we have W plus Z is 1,000. Is it possible that we could, if I shift in terms of one in terms of another, say I substituted in a couple of values, I could end up with W equals 1,000 minus Z, and that's just manipulating the equation. I could end up with X equals 100 plus Z. I could also end up with y equals 600 minus z. And so this would cancel out the two middle equations, where this would actually become, so I'm going to end up with 1001. The 1000 stays, right? Because that's going to stay as w plus z, right? And that's equal to the 1000. Nothing will change there. But in this case, if I do x minus z, I will end up with 100. So this would be 0, 1, 0, negative 1, 100. Where in this case, I'm doing x minus z equals 100. Okay, and in the third row, I could end up with 0, 0, 1, 1. The 600, that does not change. And the last will end up at 0, 0, 0, 0, 0. So we eliminated it completely. Okay, so our solution set in this case would be basically w, x, y. And the z will be canceled out. If that works, since we have w, x, y, z, we would end up with 1000 minus z, 100 plus z, 600 minus z, and lastly z as that solution. All right, so let me write that down. So we end up with 1000 minus z, 100 plus z, 600 minus z, and then z, hence w, x, y, z. Because the z is getting zapped out. If we apply this value, again, if they were to ask us to substitute in a value, say 50, so let's say they said to us z is equal to 50. So then that means that this will be 950 cars. This will be 150 cars. This will be 550 cars, and this will be 50 cars. This is just an arbitrary question, inserting z as 50 as an example. Okay, so if you need to see a little bit more of an example on this, or you want to see how we obtain these values, you can just sort of play with that. All right, I'm going to stop the recording here. So this is section 9.2 in a nutshell. And you do have a question similar to this in your homework. So you'll be practicing that.